Reggie's Corner, we are going to analyze graphs of polynomial functions. So if we look at the first example, we have a function here. And the first thing you can do is you're going to make a table of values, and then you're going to plot those points on your graph. Now, when you're plotting the points, you can use the table and or the graph to decide where it's crossing the x-axis, and that's where your zeros are. So anywhere it changes from a negative to a positive, that's where you're crossing that x-axis. So if you look here, that's where I'm going from a negative to a 0 there. And so somewhere between negative 0.5 and 0 on my x-axis, you can see that's where you cross. So right about there. We have another one as well that changes from positive and negative. So you can see somewhere between 2.5 and 3, which is right here. That is also where you cross the x-axis. All right, let's look at the next example. A little bit more detail here. You're going to determine the consecutive integer values of x between which each real zero of, and then again, it lists the function is located, and you're going to graph it. So again, first thing you would do is you would pick some values, complete your table. And again, you notice there's a change of sign right there between -7 and 1. So you know between -1 and 0, which is right about here, that it's going to cross the x-axis, right, between -1 and 0. You notice again, there's another change of sign from positive to negative, and that is on your x-axis somewhere between 1 and 2, right? That's where it crosses right there. And again, between 2 and 3, that's also where we go from negative to positive. So you know you're crossing that x-axis. So again, the sign indicates where the 0 appears, and that's also between 2 and 3, somewhere in there. Okay? Now, the next thing we're going to build on that, and we're going to do the same sort of thing. We have a table of values, and we're going to talk about the maximum and the minimum points. And we talk about relative max and relative min because we know with this polynomial function, there's arrows on the end, and so that's going to be continuous. But when you're talking about everything between those infinite measures, we're going to talk about where the maximum and minimum is. So you can actually do that, again, either from the graph or the table. I think sometimes in this case, the graph is a little bit easier. So you can see right about here, that looks like it's at about 3. And that's right there. So that right there is called your relative max. That's your relative maximum right at 3. And then your relative minimum looks right about here, somewhere in there. And again, I can look at my table and I can see that's the lowest number. And that is negative 12. So that's my relative minimum. Okay, so now again, looking at this kind of graph in general, we have the function at certain parts is increasing. It's increasing here, it's decreasing here. And again, the relative max is going to be the highest point, and the relative min is going to be the lowest point, not including where these arrows are going to go through infinity. So kind of within that graph itself. All right, let's look at one more example. Now, this is kind of taking everything from start to finish. So I'm going to give you a function, which is right there. So you have a couple directions. First, you're going to create a table of values, and I give you your parameters there between -2 and 3. Then you're going to graph the function. And then we're going to look at determining, again, two things here that we just worked on. Determining the consecutive integer, where the real zeros occur, and also finding the maximum and the minimum. Now, to save some time on the video, I completed the table and the graph already. But if you want to try yourself, feel free to pause the video and you can make sure your values work out. You really have to be careful when you're completing the table that you're paying attention to where the zeros, the negative sign is. So that negative sign is not included attached with that x. So for instance, when I'm going to put that in my calculator, that negative sign goes out front, and I have -2 to the third power plus 3 times -2 squared minus 3. So you do really have to be careful in using your calculator. So these are the values I received. Then I graphed. Okay, so now we're going to look at the real zeros. So from here, I notice right here, I go from a positive to a negative. So one of my real zeros is between -1 and 0, right? When x is between -1 and 0. I also noticed there's another change there from negative to positive. So that's also going to be between -1 and 1. Negative -1 and 1 on my f of x side, but really it's going to be between 1 and 2 on my x-axis, right? Looking at these values. And my last one, there's another change here. So it's also going to be between 2 and 3. So all of these are called, my real zeros, my solutions, my roots. You see a lot of time. Now we're also going to look at this relative maximum and minimum. So it looks like here is the lowest point, and that is going to be the highest point, my relative within the graph. So I can double check that using my table as well. So my lowest point there looks like it's -3. So my relative minimum there is going to be x is equal to 0, right? My x is going to be equal to 0. So it's at -3, but it's at 0 right here if I carry that down. And my maximum point, my relative max, is when x is equal to +2 because it's this point right here. And my x value is 2. You'll see sometimes the terminology will be, you could call it extremes, you could call it turning points, that sort of thing, but you get the general idea there. Okay, thanks so much for stopping by. You have a great day.